projects. In this video, we are going to explain about the project that is comprehensive analysis of word embedding models and design of effective feature vector for classification of Amazon product reviews. So before getting into the execution, first let us understand what is this project about. Sentiment analysis, or we call it as essay in short. So it is all about figuring out whether a piece of text like a product review or social media post is positive, negative, or neutral. With more people sharing their opinions online, especially on social media and e-commerce sites, there is huge amount of data that can tell us what customers think about products or services. This feedback is really useful. Buyers can decide whether to make a purchase, and companies can use it to improve their products or marketing strategies. However, the challenge is that this feedback is usually just plain text, which computers can't understand directly. So we need to convert the text into a format that machines can work with the numbers. This step is called feature extraction. It helps machine learning models understand the text so they can learn patterns and make accurate predictions about the sentiment. Essentially, it is about turning human opinions into data that a computer can analyze. And one of the biggest challenges that we have with in sentiment analysis is figuring out which features of the text to focus on so that model can correctly determine the sentiment. Traditional methods like bag of words, TF-IDF, and n-grams are easy to use and common, but they have a big limitation. They treat words as separate tokens and don't understand the meaning behind them or how words relate to each other in sentence. And more advanced models like word2vec and BERT they try to fix this by capturing meaning of the words and the context in which they appear. They are much better at understanding the text. But even these models struggle when that is with the certain language nuances like negations, such as words like not or never can completely change the meaning of a sentence. And if the model misses that, it can get the sentiment wrong. So, this shows that there is still need to develop better ways of representing text features, methods that are smart enough to capture both meaning and also the context, while handling tricky aspects of the language. Doing so can make sentiment analysis much accurate and reliable. So to overcome with all these issues, this project it combines the best of both words, that is worlds, when it comes to understanding text of sentiment analysis. So here, one side we use traditional models that are bag of words, TF-IDF, and n-grams, which focus on how often words appear in the text. These methods are simple and good at capturing basic patterns, but they don't understand the meaning of the words. So, on the other side, we are using modern techniques like word2vec and BERT, which are designed to understand the meaning of the words and how they relate to each other in a sentence. By combining these approaches, the system can take advantage of the both. It can see the statistical patterns in the text while also understanding the context and semantics. This hybrid approach makes the model more powerful and better at accurately classifying whether a review is positive or negative. And one tricky part of analyzing text is dealing with negations. That is, words like not or never can completely flip the meaning of a sentence. That is, they can completely flip the meaning of a sentence. So, to handle this, the system includes a special negation handling module that detects these words and adjusts the sentiment accordingly so that a positive review isn't mistakenly labeled as negative or vice versa. After the text is cleaned and the hybrid feature vectors. So here after the text is clean and the hybrid feature vectors are created, these vectors are fed into the several machine learning classifiers such as naive Bayes, k nearest neighbor, decision trees, random forest, and linear SVC. By combining careful pre-processing that accounts for negations, rich hybrid features, and strong classification models, the system is able to accurately and reliably predict the sentiment of a large number of e-commerce reviews. And to further improve the performance of this project, here we have introduced more advanced and practical tools for adding several improvements. So first, it uses hybrid embeddings, which means it combines multiple ways of representing text. But TF-IDF and bag of words along with Electra embedding has been used. So by combining these different types of embeddings and analyzing them with a variety of machine learning models, the system can understand the reviews more deeply and classify sentiments more accurately. Next comes explainable AI integration. Here, this feature, it helps to show which words or the phrases in a review are influencing the model's decision. Here we are using Lime for that. It makes the system more transparent so users or developers can see why a review was marked as positive or negative rather than treating it as a black box. And then comes front end part. So here, to make the system accessible, a web interface using Flask has been developed. Users can log in securely and input their reviews to get predictions immediately. This makes it practicable for use where people can interact, that is where people can interact with the system directly. And at last, topic modeling. That is where the latent dirichlet allocation model is applied to the reviews. This helps the system to identify main themes of the topic discussed in the dataset, providing additional insights beyond just sentiment. For example, it can reveal whether people are mostly talking about product quality, delivery, or customer service. So these are the things that we have incorporated. And moving on to the implementation. To implement this project, here we have followed the steps which are mentioned below in the flow of work. So let's understand how we have implemented the project. First, we import all the necessary libraries. These include tools for handling data, that is using pandas and numpy. For text pre-processing, we will be loading NLTK. We will be loading embedding tools, that is embedding libraries, machine learning libraries, visualization libraries, and web development libraries. And then comes data ingestion part. So here the Amazon review dataset is loaded into Pandas data frame. This allows the raw data to be structured into a tabular format, making it easier to manipulate, clean, and prepare for analysis. Then comes pre-processing. Here in this stage, the dataset is clean and standardized. Text is converted to lowercase. Unnecessary elements like HTML tags, URLs, and non-printable characters are removed. Punctuation is handled according to the model requirements, and the text is tokenized into words or sequences. Sentiment labels are encoded numerically for the classifiers, and n-grams are generated to capture sequential word patterns that can improve model learning. And then comes embedding, or we call it as vectorization. So the clean text is transformed into numerical feature representation. This includes traditional techniques like bag of words, that is BOW, TF-IDF, which is term frequency, inverse document frequency, and n-grams, and contextual embedding like word-to-vec and BERT, and hybrid combinations like BERT with TF-IDF and extended embeddings for better performance such as BERT, TF-IDF, bag of words with Electra embedding with Electra model. These methods allow the model to capture both the statistical and also the semantic aspects of the text. Then comes data visualization. So visualization is used to better understand the data set. The distribution of sentiment classes is plotted to see the class balance, and word clouds highlight the most frequent words or phrases, providing insights into common opinions and the trends in the reviews. Then comes feature extraction. So here in the step, pre-processed text is converted into numeric vectors using the chosen embedding or vectorization method. This step transforms textual information into a format that machine learning models can process effectively. Then comes data splitting. So here in this step, the dataset is split into training and testing sets. This allows model to learn from one portion of the data and will be evaluated on separate, unseen portion, ensuring that performance metrics reflect true generalization. Then comes model building and training. Here, various machine learning classifiers are trained on the feature vectors. This includes baseline models like naive, Bayes, k nearest neighbor, etc., as well as extended approach like XGBoost combined with hybrid embedding to enhance the classification accuracy. Then comes evaluation. So here in the step, we evaluate all the models using metrics like accuracy, precision, recall, and FN score. And confusion matrix are examined to identify false positives and negatives. Explainable AI techniques, specifically LIME, is applied to show which features contributed most to the predictions, helping to interpret and trust the model predictions. And then comes saving the artifacts, that is, the model which performs best will be saved for the future use. Then comes model deployment. So here at this stage, a Flask-based web application is built to allow users to input reviews for sentiment analysis. The app applies the saved pre-processing steps and embeddings to the input, predicting the sentiment, and performs topic modeling by using LDA to highlight key themes in the text. The results, including predicted sentiment and topic insights, are displayed on the web interface, making the system interactive and user friendly. Moving on to the algorithms used, these are the algorithms used in this project, and these both are the extension models. And to implement this project, we need basically hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. And these are the source code files. Now let's understand each of them. So in this folder, we have the dataset, Amazon review dataset. So here we have train dataset that we use models to train. It's loading, just wait for a while. Until it opens, let's see the other files. So get back, get back. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap files which are important for the project's appeal. And here we have template folder in which we have HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases folder in which we have test cases that we will be using in the front end. And this is the app.py file. So this .py file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests and interacting with the database. And also generating dynamic content that is to be rendered in HTML templates. So your dataset has been opened. So that is why it is asking like that. Click on OK. So here we have the dataset. So this is the dataset that is used in this project to train the models for predicting the sentiments in Amazon review dataset. So this is the Amazon review dataset based on the products. Now close this, open the code folder. And here we have multiple Jupyter notebook files. So here we have Jupyter notebook files. So these files, they contain a combination of code, graphs, and outputs all in one place. And they allow users to write and execute code in individual cells, which makes it a popular choice for the data science projects. Here, this is the BERT model Jupyter notebook file in which we will be doing feature extraction using BERT model, and we will be training all the classification models on the BERT extracted features. Accordingly, with the BO, that is bag of vectors, hybrid model, here we will be combining multiple models. And here we have TF-IDF with variations. And this is the signup.db file, which is a database file. And this is the topic modeling file in which we have latent directlet allocation model. With that, we will be doing topic modeling in the project. So this is all about the code folder. Now let's execute it. To execute, copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So it is open. Here, Anaconda prompt is open. Give the command cd, give the space, paste the copied path. Now click on enter. Here you can observe current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it into any web browser. So I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of this project. So now click on get started. And here you need to create an account and then sign in. I have already created account, so I'll directly sign in. For creating account, you need to fill in all these details. So I'll directly sign in now. And give your username and the password. Click on login and we are redirected to prediction page of this project. So here you can see a text box, right? In this we are supposed to give input message for predicting the sentiment of given Amazon product review. So let's open test cases for that. So let's open it. Open test cases. This is the sample file. So here we have label. Let's apply filter to it. And let's apply filter to class 1 and click on OK. Now let's try predicting this text. Copy it, get back to the application, paste it. You need to copy the text, not the title. So here we have copied the text and pasted it. Now click on analyze. So this given text will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us a prediction. So here we got the prediction that it is negative. So given text is negative with a confidence of 99.78%. So this is the review that we have given. That is the text we have given. And these are the important words of this text. Now let's check with the other text. So click on analyze text. Just wait for a while. It's being loading. Until then, let's copy text. So let's copy this one. Get back to the application. So it's loading. So let's copy the text here. Paste it. Now click on analyze text. And here we got the prediction that it is also negative. And here we have confidence score for that. So here the review contains negative sentiment and disappointment with the product. So these are the key topics for this particular text we have given. Let's try with the other class. So get back, open label, apply filter to this, class 2, click on OK. And let's copy this text and paste it the text here. Now click on analyze text. And here we got the prediction that it is positive text and with the 98.41 confidence. And the review expresses positive sentiment and satisfaction with the product. And this is the text that we have given. And here we have topic modeling results. Let's check with the other one. Click on try another. Now let's check with this case. Paste it. Click on analyze text. So here we have prediction as positive sentiment, which is 99.72 confidence we have. And this is the text we have given. And here we have the key topics. So here class 2. Class 2 refers to the positive text and class 1 refers to the negative text. And this application is exactly correctly predicting the text to be positive or negative. Here you can analyze the results. Now let's check with the graphs. Click on graph. And here we have charts. So this is the confusion matrix where on x-axis we'll have predicted labels and on y-axis we have true classes. Let's close this. And here we have accuracy over epochs, that is accuracy over multiple iteration. Here with the number of iterations you can observe, accuracy is increasing. Here on x-axis we have epochs and on y-axis we have accuracy. So this blue color line, it represents training accuracy. This red color, that is orange color, it represents validation accuracy. Now close this. And here we have loss over epochs. This is the loss over epochs. Close this. And here we have model metrics. So here if you observe, here on x-axis we have all the models that we have trained and on y-axis we have accuracy. Similarly here also. Here we have accuracy, this is the precision and this is for recall embedding classifier. So this we have done for the extension model. This is the recall by embedding and classifier. And this is F1 score for recall embedding and classifier. Now close this. So here if you click on all, you will get all the graphs. If you click on data, you will just get the graphs related to data. If you click on metrics, you will get graph related to only metric. Now click on log out. So in this project, we built a system that can understand and analyze customer reviews, helping both the buyers as well as sellers to make better decisions. It reads the reviews, identifies overall feeling, and even highlights the main topics, making it easier to understand large amount of feedback quickly and clearly. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.